Hello, everyone. Welcome to Cloud Console Cartographer. We're going to be talking about mapping and the role that it plays in understanding the extremely verbose nature of AWS logs in console sessions. And then I'm going to turn on my pointer here. All right, so we're going to do an introduction of the kinds of logs we'll be looking at and the nature of our research. We'll then talk about the kind of general problem of how noisy these logs can be. And as a defender, when you look at all these raw logs, how do you make sense of what the attacker or legitimate user actually did in the console session to produce these logs? We'll then talk about the solution and lead in the end to a demo of our open source tool, Cloud Console Cartographer, that anyone can use today to make better sense of these verbose logs.
Minasan, konnichiwa. My name is Andi Ahmeti. I come and live from Kosovo, which is a state in Europe. I started working as an associate threat researcher at Permiso Security for almost a year now, and I've developed an open source detection framework, which is called Cartographer. So I've attached the link below, so go ahead and give it some love, and let me know if you have any questions.
Andi is also a huge Lakers fan. Hello, I mean, who's not? Come on. My name is Daniel Bohannon. I'm from America. I love coffee with a passion. More than the coffee, I love the conversations with friends that happen around coffee. That's the most meaningful part to me. Also love motorcycles. I do not have that motorcycle. One can dream, but anything on two wheels is still quite fun. I've been in IT security for about 14 years. I spent 5 years at MANDIANT doing incident response consulting, then moving on to their advanced practices team doing security research. I spent a lot of time developing obfuscation techniques for detection purposes, and then spent 2 years at Microsoft doing threat hunting and the Windows Defender telemetry. And now for the last year and a half, I've been at Permiso Security, focused on cloud security with several friends that I've met along the years at MANDIANT. And so a couple of the obfuscation tools are there. But yeah, that's a little bit of my background and super excited to be here today. So as a defender, logs are really important. They give information. And so our advice is use that visibility to your advantage. Secondly, enable the logs that are not enabled by default. Attackers will not do this for you. So understand what's there, turn it on, and then most importantly, do something with it. Forward it to a secondary location to ensure that an attacker has to work extra hard to delete that evidence. This is where, depending on the log source, you have to use new tools or techniques to be able to efficiently find answers. You need to aggregate, correlate, and then ultimately search for malicious or anomalous activity. I come from a host endpoint background. There are a lot of differences, in my opinion, from moving towards cloud logs. Host and network logs, and again, when I say on-prem, I'm talking about like the originating log source, not how they're stored. So if you have like an endpoint, with like sysmon logs or anything like that, they're extremely granular. There is a wealth of information about image loads, file contents, all these things that when it comes to doing incident response or threat intel, you have so many fingerprints of the attacker left in that operating system from a forensics perspective. It's super interesting, a lot of fun. I miss it just a little bit, but there's a lot of information in a lot of directions that you can go. Cloud logs are quite different. You don't have nearly as much control over it. It's up to each cloud provider to determine what to give you. There is no aftermarket sysmon you can plug in. Like, there's nothing like that. There's also a bit more of an abstraction. Cloud logs are typically broken up into control plane and data plane. Control plane is what's often enabled by default. This is giving you information about configuration changes. Data plane is typically not enabled by default because it's the usage of the cloud infrastructure. It's usually not enabled because it's a lot of data. It'll cost a lot of money to store that data, and a lot of people do not enable it by default. There's also a delay in log generation from cloud providers that one should be aware of. Retention limits is a huge reason to forward logs. In the last presentation about Azure AD, that's a 30-day retention limit. Like, if I'm investigating my infrastructure, I want a lot more than 30 days to go back. CloudTrail logs are sitting at 90 days. That's better. I want more than 90 days. And if you want more than 90 days or 30 days, you need to be making copies of those logs in systems that can hold it for a lot longer. And finally, these logs are a bit abstracted and less granular because these are basically logs of API calls. These are not logs looking at an attacker system. or an organization system that's been compromised by an attacker. You're abstracted all the way into the cloud environment and just looking at the API calls that were made. So we have to generate fingerprints by correlating a lot of more abstracted logs, which is a really fun challenge, but again, quite different than on-prem logs, if that's what you're used to. If you haven't looked at cloud logs, here's a quick example of an AWS log and an Azure activity log. In this case, just creating a user. So there are some similar kinds of fields, but ultimately, when you look at a lot of specific examples, these are very different log types. Azure does some really strange choices in how they log things, and it makes it quite complicated when you're trying to get to some of the information, though that is not the purpose of this talk. There are many different ways you can query these logs. You can use the built-in API, which again is going back to that retention limit. You can't query back more than 30 days or 90 days for Azure AD and CloudTrail, respectively. One of the pros, though, is it's not quite as delayed as the log forwarding. Also, when you forward logs, that's introducing another hop. So that's one more thing for you to monitor to make sure, are those logs still flowing? Has anything stopped the flow of those logs? So you want to make sure that you're monitoring each step of the way as it applies to your information. But when you forward the logs, you can store the logs as long as you want. There is no API throttling. So for example, CloudTrail only allows you to call the lookup events API 2 times per second. That's plenty for a lot of people. That's not enough for other organizations. And this is shared across the environment. So if you have 10 different security vendors all hitting that same API, they're going to start hitting that throttling limit and having to deal with that. And that happens pretty commonly in a lot of our customer environments. So if you forward all your logs to, let's say, an S3 bucket or an Azure storage blob, there's no API to deal with now. Everyone can read off of that storage location. It's easier to consume by other tools. One of the cons, though, is sometimes the data is actually missing in some of these. A really weird example of this is AWS logs. If you query events in the API, there's an entire resources section, which is quite cool. It basically lists resources referenced in that event. If you forward that to S3, that section is just completely gone. So it's really important for any DFIR practitioner, know your tools, know your data, test the data using different tools, and make sure you understand, tools are all written by humans. We are not perfect, we make mistakes. Same goes for your IR tool. So it's important to look at that before you have an incident and really, really need it. So for this presentation, when we use the word console, we're not referring to like a command prompt kind of console. AWS defines their web browser management console. That's what they call it. Azure calls it the Azure portal. But again, when we use the word console, we're referring to web browser interactive, clicking around, doing stuff, not the CLI. So why would we talk about console? Do attackers really use console? The answer is yes. And there's some different reasons that we see attackers using console. I won't go into specific details of these attacks, but we've responded to multiple incidents where attackers are using console. Sometimes the attackers are also learning cloud. They're just trying to get the job done. Maybe their playbooks are PDFs of click here, do this, do that. But there's also sometimes where there's a technical limitation. We responded to an incident last year where an attacker, there's an ECS container breakout, and the very first thing they did with that federated token was a console session. Now, it's interesting because if you look at AWS documentation, the federated token does not have the ability to hit the IAM service programmatically, but the console does not apply. That limitation does not apply. So they immediately went to the console session, created a new user, did all this stuff in IAM. So it's an interesting choice. I don't fully understand the reasons why this is the case with AWS, but there are sometimes technical reasons why attackers will use console sessions. So it's relevant. Now let's talk about what the problem looks like.
Cool. Now let's get back to the logs. We saw 2 examples that Deepo presented, and they both were change events. So we're adding a user in Azure or AWS. But what if we're trying to do some enumeration steps? And we know that listing users, listing roles, policies are just read-only events. We're not really changing anything. And surprisingly, after doing these clicks and AWS, we see a big log volume. Whereas if we are trying to do the same steps in Azure, so list user, list blobs, wherever, Azure does things differently. So they only logs change or update events, and that applies only for the Azure portal. And if we're trying to do only read-only events, only enumeration steps, would be muted. So we have no logs generated at all for these clicks. And for that, Azure kind of gets a free pass from our problem, not because they are doing a better job at this, but since they don't even offer enough logs to actually make sense of what's happening if an attacker is enumerating in the environment. And for that, we're going to focus only on the AWS, where we can get enough logs and enough data to have a solution for our problem. Now we're trying to explain the problem or the main part of our presentation, which is the noisy console logs. So we all love logs here. Every security person does. And they shine our path towards the truth and who did what and when. But sometimes too much logs can leave you out in the dark. And the problem here is not the absence of logs. It's actually the sheer volume of them. So sometimes looking at these logs, it feels like the Atari Super Breakout game, where each time when the ball leaves the paddle is like a user clicking a button in the console. And that ball sometimes can hit only one square, and that means we can correlate that to one request and one response. But sometimes the ball can go way over to the top and hit tens, maybe 100 of brackets, and that could be translated to a single click that can call 10 or 100 of API calls in the back. And we're going to see later on our slides that that's actually the case in some of our session that we have prepared. Back to you.
Yeah, high scores are not good when it comes to logs in that analogy. So the way that we basically started this was we gave ourselves an IAM user with no permissions, absolutely no permissions. We just gave ourselves a login profile so we can log into console. And what you'll notice is that if you start clicking around, you'll see all these errors, and it's specifically saying, hey, you don't have access to this API or this one. This is in the console home. If we go to the IAM dashboard, we'll see even more APIs that we need access to support that tile, that widget in the web page. And lastly, let's go to users. If we're trying to list the users, there's one more. Hey, first thing we need to do is list the users. Well, if we're trying to understand, let's say if for this input action for when someone goes to the IAM service and clicks on users, what are the APIs that are being called? Well, let's give ourselves access to run list users. Let's just add a little inline policy. So now we can run list users. What happens next? Well, we can list our users, but we can see all those other columns have additional errors. Instead, well, yeah, so what we're trying to do now is say, okay, for each input action, how do we efficiently enumerate all the APIs generated by that input action?
Now, if we want to look at the data that Debo just mentioned, we need to crack open the hood and let's see what treasure is inside of it. So we have 4 golden rules that we love and live by. The first one is having full permission on your environment, because you don't want to lose time at giving manual permission to our user every time we're trying to do something. Having a new environment for each service, lots of Excel spreadsheets where we track our time of our actions, and Deepa's favorite one, which is lots of coffee or any coffee and drink of your choice. Now, let's get back to 3 scenarios where for each one we are running or we are firing the list user action. But this time we have 3 different scenarios. The first one, scenario A, is where our user has no permissions at all. Scenario B, where our user has the list user action, which we gave previously with the inline policy, and scenario C, where our user has full permissions. Now let's see what events are generated for each scenario. For scenario A, we have only one event generated, and that's the event name of list users, which was obviously denied. So only one event for this scenario. Moving down to scenario B is where things start to get more interesting. So we see that the first action, the list user, is actually successful. And we have a 5 grouping of events which were denied due to lack of permission, but they happened. Now moving down to scenario C, we see that those 5 grouping of events were successful and they occurred once per identity. If we check at the request parameters, we can see that we have only 3 users present, so they happen 3 times each. And we see that these 5 grouping of events happen both times in scenario B and C, and we know that they are gonna happen, so let's just keep them to our side. Now, shifting our focus to the bottom 2 events, we have the get access key lost used, which it's interesting here because a user, as we know, can contain 0 up to 2 access keys, but that 0 means something, and that means that a user may have none, so this event might never fire. And our solution to this problem is, let's group these events in 3 categories. And the first one is the anchor event, which is the main event that will happen, the required events, and lastly, the optional event, which again is an event that may happen, but if not, it's not a deal breaker.
So for the optional events, these are still valuable for us to track for 2 reasons. One is we want to say all these events correlate to this one input action, but there's a lot of information in those optional events. As Andi said, these optional events actually list the usernames. So just by taking event logs, we can actually see what IAM users were present on that page that the attacker or identity was looking at. So one of the aspects of our tool was gathering all the events we can, but then mining information out of it to put it into the final kind of new event that we are creating to capture all that information. So it's actually quite interesting, especially when you look at sessions generated by an attacker. It's like, well, when they listed the identities, why did they click on this audit user first? Well, look at all the other users that were present. If I was an attacker, that is the most interesting identity that I would click on first. And so it's actually nice to have that context. But there are 2 kinds of optional events. One is what we call background events. In this case, if you log into console home, you have all these events we kind of highlighted in a light blue to say these are just happening all the time, not related to clicks. So if you have a console session open for 5 hours, if you go on a really long coffee break, you're going to have these events just going on in the background. We don't want to link those to input actions because they're not linked to it. So we categorize those as optional events. We just want to slide those out of the way and not factor them in to our analysis. The second kind of optional event is based on context. The things that are present in the environment matter. If you have 3 users versus 100 users, that's going to affect the amount of logs that are present, but it's even more than just counts of things. So what we did, we were really hungry when we got to this point of our slides, is let's create what we're going to call the everything bagel and the plain bagel user. So everything bagel is a user that just has everything we can imagine added to it, every kind of permission. So for this identity, we've added inline policies, manage policies, a permission boundary. It's part of a group that has policies. We added tags. We added security credentials with a login profile, multi-factor device, 2 access keys, both active, SSH public keys. I mean, again, everything we can add, we added to it, even a signing certificate just for the heck of it. The plain bagel, nothing. Like nothing at all, no policies, no groups, no login profiles, anything like that. So let's do a couple clicks and compare the differences between an identity that has all this context versus one that doesn't. So if we click on an identity onto the permissions tab for the plain bagel user, these are the events that we get. Everything bagel has a couple more. So now if we were to compare these 2, then, oh, actually before that, you'll actually see for the get access key last used, AWS can't even make up its mind about which user agent to use sometimes in the same service. One thing that we learned by mapping different services is there are completely different teams of humans that do all these different services because it's massive. They have different styles of writing code. They have different styles of user agents and all this stuff. So even the background events you have in the IAM service are going to look very different than background events you have in EC2 or ECS, it's quite interesting. But yeah, even in the same service, sometimes you'll see different user agents. But if we were to group these differences, we'll see most of these events are the same, which are highlighted in the green box there. But then the yellow and purple boxes are going to be some of those differences. So get access key last used is the more interesting one to me, but there still are some differences. And this is not limited just to one tab. If we were to click on the security credentials tab, we're going to see a pretty similar situation where we have most events the same. But again, if access keys are present, then we have those as additional events for that identity. 1 event per identity or per access key.
Yeah. Thanks for the bagel, Zibo. Definitely made us hungry, so you'll have to buy me after our talk. Now, we saw some events during Debo's previous slide, and let's take a step back and actually see what if we run these events from three different perspectives. The first one through the AWS CLI, the second through Boto3, and the last one from the web browser. Now, let's see what actions we are talking about. The first one is creating a user named Krideva, creating an access key for this user, and attaching a user policy. Only three. Let's see what events are generated in the back. Cool. We have only three events that are generated from these three actions. That's what we expect. We're only doing three actions. And with some differences in the user agents, and we can see that the event source and event name are appended at the back of each action that was run. Moving down to the Boto3, same three steps, same three output events in CloudTrail with one small difference where the user agent now is simpler because it's the same across all the actions. Going to our lovely console, now we're going to do the same three steps, but as we know, we need to sign in into the account, do different steps to get to the IAM service dashboard, create a user. So we're going to do a roadmap of each click that the user needs to make in order to recreate the same three steps. So buckle up and let's see what's going on here. The first step is the console home, where we are signing in, and is the first home page that we get redirected. So for that, we've been awarded with 13 logs. Let's get to the site and keep track. Search bar. Who thinks that even just searching for something in the search bar or just clicking the search bar placeholder fires an event? Well, it does. It has one event. And immediately after clicking the IAM service icon, we get thrown to the IAM dashboard. So we have 9 events in total. Click the IAM user breadcrumb, and it generated 18 events. And we were lucky at this time because we had only 3 users available. And this is a pretty good, decent scenario. And we're going to talk later on slides about some worst case scenarios. So we had only 18 events generated. Now we are starting to reproduce our steps. So we click the create user button, which generates 4 events. Immediately, we need to attach a policy to this user. So we have 15 events. Now we are creating the user, the last step, which generates 3 events. And immediately we get redirected to the permission tab of that user. So 13 events in total. And surprisingly, only 1 event generated when we are creating an access key. Ooh, that's a lot. Now, in the user agent perspective, we see some varieties of them. We have some internal user agents, some Java versions, and only 10 events which were actually generated from our real browser. If we see on the version of these user agents, and speaking about the Java versions, we see some differences between them. So when baselining this data, we need to make sure to normalize first these columns. Now, let's get back to the total number of events. AWS and Boto3, 3 input events, 3 output events. Very nice. Going to the console, for these 3 actions, or 9 clicks in total, we have 73 events generated. So I talked about the worst case scenarios, and here we are. We thought it would be funny and interesting to come with a mathematical formula to kind of predict how many events will be generated. And we have the same action, which is the list users. So we have that constant one, which is the anchor event. Moving down, we have 5 times n, where n is variable, and that's the number of users. So we have 3 users, it is 15. and the lost events, which are get access key, which again, a user can contain 0 up to 2 access keys. In our case, we had only 3 available users, so 0 up to 6, and we had only 2 access keys present, so 18 total. But what if we increase the number of IAM users? So if we increase to 20, we'll get 141 events. Let's increase that by 50. We have 351 events and lost. If we have 100 IAM users available, we'll get 701 event generated by just clicking the users button in the IAM service. We came with another approach to a different service, and that's the S3 bucket, where we have 21 guaranteed events that are going to happen, and 4 times n, where n is the number of available buckets. So 421 in total.
Yeah, so everyone's winners, logs for everyone. In summary, how do we aggregate these logs? That's what we're trying to do. We look at all these individual pieces, group them together so that we can have meaningful data to look at as defenders, so that we can say, you know, these are all the individual events that correlate to clicking IAM users, and then the creation of a user, creation of an access key. And then, by the way, let's track all those background events so we can get them out of the way and focus on the events that matter to us. So let's do a little bit of, oh, hold on. I just discovered a new, no, I did not discover a new button. I just skipped. All right, cool. So the way that we do this in the tool is we have a 2-pass approach, labels and signals. First, we go through all the individual events, and this is actually how we explain the events in the open source tool that we'll discuss in just a moment. So we define what's the click, what's the metadata around the click, what's the general description, and then what are the events that are required, optional, etc. There's a lot of details in this project that handle some really difficult situations. We'll leave that for another time, but that's the simplistic way to look at it. So the first pass, go through every event, add specific labels based on the API information, request parameters, response, user agent, all those sorts of things. And a single event in a single situation can have multiple labels applied. The ordering is very much important. The second pass then goes back through all those events with the labels, and it stops at events that are categorized as an anchor event. And then we'll stop at that event, go through all the labels for that event, and then look behind and look ahead and gather all the other events that have the same label, and then group that summary together to then say, does this satisfy the signal definition for this click? If so, generate a signal and flip a flag on all those events saying all these are now contributing to the signal. They cannot contribute to another signal. If that is not matched, we go to the next label and do the same look ahead, look behind stuff. As I mentioned before, we extract all this information from those optional events so that we can modify the summary of that click. So we can do a lot more than just say the user clicked IAM users. We can say they clicked it and there were 33 users present. Here were those 33 usernames, and there were 14 access keys active at the time. Here are those access keys. Those are the kinds of things that we can do, as well as modifying the URL so you can see, how do I get back to this exact same click in a console session if I have the same privileges. There's a lot of fun tricks we built into the tool to do look backs and look aheads for signal merging, signal modifications, and sometimes you have to look at a previous signal to extract metadata from that signal to pull forward into the current one. So I still get a headache when I think about some of these scenarios, but just know there's a lot of fun stuff in there. So let's do a demo. In this demo, we're going to simulate. This is actually not fast forwarded. This is just a really speed run going through the AWS console. Let's do a couple clicks, and then let's use our tool to see what it looks like. So we're going to start by going to the IAM service. We're going to click on user groups, click on users. We're going to click on one user, in this case, the Petula user. We're going to click on a few tabs. There's no login profile. So an attacker might want to come in and say, yeah, let me add a login profile so I can use the console session. There are 2 active keys. An attacker might want to get a new one. So you have to first deactivate a key, then delete the key. And that's what we're doing right here. And then let's create a new key. So as an attacker, I can look at that key material and have access to that key. So that's what we're doing right here. In this case, we're not just going to look at the material, but that's some stuff we did in IAM. Let's go to the search bar. Let's go to Secrets Manager. Let's enumerate some secrets. And so this is an example we saw an attacker do where they were manually going through looking at secrets, and then they actually wanted to do it a little more programmatically. So they opened up Cloud Shell to give you that CLI access right there in the management console, where they uploaded a Python script and then enumerated those secrets. And so I'm actually going to skip ahead to the next video, but we do a little bit of S3 enumeration and a couple other things in there. But the important part here is if you get those raw logs, then what does it look like to actually use the tool to aggregate that data? So on GitHub, we'll show the link after this. We actually have some demo events that you can use to go through all these steps of adding the signals, adding the labels. And basically for the labels and signals, we keep all the original input logs and then add in another enrichment property that contains all of that information. It contains the original event and then all the enrichment data. If in this case, there's actually no signal present. So let's go and find one where there is a signal present based on some of the activity that we just did. So let's look for cases that do have an enrichment object. This example here is the list users. So here you can see we actually extracted all of the identities, the IAM users, as well as their access keys. We put that into the string summary, but then we also kind of keep this raw data object as well. So you can just programmatically access all the list of values that we pulled together from all those events at any time if you would like to do that. So that was the initial IAM stuff. This is not the most helpful way to look at this data if you're trying to write your own mappings or even just review it. So we have the show event summary, which is going to show event by event which events were mapped, which ones are part of signals. And this is really helpful for debugging. I'm going to skip ahead just another moment. But there's a couple more features in there for when you're debugging and you want to see what labels were applied, which ones were tested, et cetera. But really the most helpful way to look at this is at kind of like the whole session, like just tell me the clicks. I don't need to see all 1,000 events. What are the clicks that were present? And so here's a CLI view of that where we can see 2 events, 484 events were for that user's click, et cetera. And we try to highlight the new values that were pasted in. I love CLIs. I think they're really fun. Not everyone does. And so Andi had the brilliant idea to bring in a little bit of front end work.
Yeah. So me and Debo were really motivated to do some front end work, and we decided to come up with a UI where after the tool is run, we populate it. And yeah, so this is our UI. It uses dash AGGrid in the back, and it has all the cool features that AGGrid has to offer, like sorting by the column, switching the columns, order, also applying different filters like contains and stuff, just to make it easier for you guys when running our tool.
All right, so demo, last slide. What are the 3 takeaways here? Threat actors do use console sessions. They use it sometimes for technical reasons or for skill reasons. It works. It gets the job done. At the end of the day, that's what any good threat actor is going to do. Do what it takes to get the job done. Second point, make sure as a defender, you know your logs, you have them configured, you forward them somewhere, and you do something with the logs. Look at the logs. Even if you're setting up a cron job to grep through them, that is better than nothing. You want to be familiar with those logs before an incident and not try to figure them out during an incident. And lastly, you can use the tool we just did the demo for, which is called Cloud Console Cartographer, which after this thank you slide, you'll see is available at this URL down here on the Permiso Security GitHub. With that, we just want to say arigato gozaimasu. Thank you very much for your time. And we're here for questions. I think we're right at time, so we'd love to hang around and ask and chat with you all. But thank you very much.
Thank you.